Right, that occurs, and in this video we'll be looking at oxidizing agents and reducing agents. What are oxidizing agents? As we have previously learned in a previous lesson, that oxidizing agents are electron acceptor. They are actually substances that have ability of accepting electron from another species. Alright, let's look at some examples of oxidizing agents. Majorly, when this occurs as elements, they normally occur as non-metals. And when they occur as compound, it can be hydrogen peroxide, it can be chlorine, or all halogens. They are all oxidizing agents. In fact, that's one of the general properties of halogens. They are oxidizing agents. And acidified potassium tetraoxomanganate 7 is a strong oxidizing agent. Acidified potassium heptazodichromate 6 is a strong oxidizing agent. Hot concentrated H2SO4 is an oxidizing agent in the concentrated form. Then conc HNO3 is an oxidizing agent. In fact, it's a very strong oxidizing acid. That's why you cannot use it to produce hydrogen gas in the laboratory. The silver salts and metals that are low in the activity series, they are oxidizing agents. They have ability of accepting electron more readily than those higher up in the activity series. So they are actually oxidizing agents because they can be reduced easily. They have very high reduction potential. They can easily be reduced. What are reducing agents? Reducing agent is an electron donor. Substances that have ability of easily donating electron, and without fetching weight very further, you will see that metals, especially those that are very reactive, they are the ones that easily lose electrons. You call that electropositivity. So most metals are highly reducing in nature. They are reducing agents, while non-metals are oxidizing agents. Other examples of reducing agents are hydrogen, carbon, potassium iodide. In fact, potassium iodide is used for testing for oxidizing agent because of its reducing ability. Hydrogen sulfide is a reducing agent. Sulfur 4 oxide is a reducing agent. Iron 2 salt is a reducing agent because it can easily be oxidized to iron 3 plus. And don't forget that oxidized species, they are reducing agents. So sodium and metals that are highly reactive in the activity series are reducing agents. They have ability of quickly donating electron or losing electron. Ammonia is a reducing agent. How do we test for oxidizing agents? There are some reagents that are specifically used for testing for oxidizing agents, and these reagents are actually reducing agents. So you can use reducing agent to test for oxidizing agents, and you can use oxidizing agent to test for reducing agents. So one of the examples of substance used to test for reducing agent is potassium iodide. When you react potassium iodide with a substance that is an oxidizing agent, iodine will be liberated, and iodine has a reddish brown color when it's been liberated. If you add starch solution to that iodine, it gives you a blue-black coloration. Is a confirmation that iodine has been liberated, and is a sign that the compound that liberates iodine from potassium iodide is an oxidizing agent. Another example of compounds that are normally used to detect oxidizing agent is iron 2 chloride. Usually iron 2 salts are green in color, and when they get oxidized, they become iron 3 salts, and these iron 3 salts are brown in color, as you can see from the screen in this place. Now, what happens when a compound is an oxidizing agent and you use iron 2 salt to test for it. So an oxidizing agent will change the color of that iron 2 salt from green to brown, and the chemistry behind that reaction is that iron 2 ion, which is green color, has been oxidized to iron 3 ion, which is brown in color. So that is how you use iron 2 chloride or iron 2 salt to detect oxidizing agents. You can also use hydrogen sulfide. Usually when hydrogen sulfide reacts with oxidizing agent, it is oxidized to sulfur. Now the reason why you call that oxidation is because sulfur in H2S, the oxidation number of sulfur is -2, and sulfur as an elemental substance is 0. So now you can see that sulfur has been oxidized from -2 to 0. That's an increase in oxidation number. So H2S has been oxidized to sulfur, and sulfur normally comes with a yellow color because that's the color of sulfur. So when the compound is an oxidizing agent and you react it with H2S, there will be a yellow deposit of sulfur. So that's the explanation, because the sulfide ion in H2S is oxidized to elemental sulfur. You can also use sulfur 4 oxide as a test for oxidizing agent. When you bubble SO2 gas into an oxidizing agent solution, it gets converted to SO42-, that is tetraoxosulfate 4 ion. So once you have done that, you can test for the presence of SO42- by using acidified barium chloride. You know that already, that when you add acidified barium chloride to a solution that contains SO42-, a white precipitate will be observed, and this white precipitate will be insoluble in dilute hydrochloric acid. So that's how you test for oxidizing agent. Now, how do we test for reducing agent? The same way you use oxidizing agent to test for reducing agent, just like you use reducing agent to detect oxidizing agent. So an example of a compound that you can use to test for reducing agent is KMnO4 acidified. Now the color of KMnO4 is purple. If you bubble a reducing agent into purple acidified potassium tetraoxomanganate 7, it changes from purple to colorless, and the chemistry behind that is because the ion that has purple color is MnO4-. MnO4- is a tetraoxomanganate 7 ion, so it gets converted to Mn2+. That it gets reduced to Mn2+, and that Mn2+, the color is pale pink or almost colorless. So you said that reducing agent will decolorize acidified potassium tetraoxomanganate 7. You can also use acidified K2Cr2O7, that's potassium heptaoxodichromate 6. Now, when you bubble gases or substance that are reducing agent into K2Cr2O7, the color will change from orange to green. That's a sign that the compound is a reducing agent, and the chemistry behind that is that the Cr2O72- that has orange color will be converted to green chromium 3 ion. So that green chromium 3 ion is the reduced product of a K2Cr2O7. You can also use iron 3 chloride. Iron 3 chloride is an oxidizing agent, just like iron 2 chloride is a reducing agent. So if a compound is a reducing agent, it changes the color of iron 3 chloride from brown to green, and you know that green color is iron 2 ion. So iron 3 chloride will be reduced by oxidizing agent to iron 2 chloride, and the color will change from brown to green. Let's look at this short exercise before we leave on this topic and continue with the topic in the next video. So we have this question. We're told that an element P has a configuration 1s2, 2s2, 2p6 and 3s2. That we should write the configuration of the ion of P, that is when P is in the ionic state. So what I'm going to do first and foremost is convert this configuration into electron distribution, that is into K-element configuration. So that will give us how many electrons now? 2 electron plus 2 electron making 4, plus 6 electron making 10, plus 2 electron making 12. So that element has 12 electrons. So you configure it as a 2, 8, 2. Now very clearly the element is in group 2. The element is a metal, is an alkali metal. So what will be the ion, that is what will be the ion of the element? Surely the element will lose 2 electrons to become stable. So that means the element will become element P2 plus. P2 plus means it will lose 2 electrons to become stable. So the ion will be 2 plus. That means it will lose 2 electrons. So what will be the configuration of the ion? That's the question. So now we are having P2 plus, which means 2 8s, since the 2 electrons have been lost to form ion. So we are going to be having a 1s2, a 2s2, and a 2p6. That will be the ion of that element 2 8. Now number 2 now, write the most likely formula of the chloride of P. Now P has 2 valence electron. That means the valency is 2. Don't forget that. Chloride is from chlorine, and chlorine is number 17. That's 287. Now the valency will be 8 minus 7. 8 minus 7 because whenever your valence electron is more than 4, your valency will be 8 minus that valence electron. For example, 285 now, the valency will be 8 minus 5, that's 3 or 5. 286, valency will be 8 minus 6 or 6. 287, valency will be 8 minus 7, so that's 1. So now chlorine is 287, so valency is 8 minus 7, that's 1. So now to form a chloride with P, now you exchange their valencies. So P will exchange valency with Cl. That will give us a PCl2. A PCl2. So that will be the formula of the chloride of P. Now the reason why this question came up is number 3. He said we should state whether P will be a good oxidizing or reducing agent. Now because P will ionize by losing electron, it will be a good reducing agent, because reducing agents are electron donor, electron losers are reducing agents. So because P will form ions by losing electrons, 2 electrons for that matter, so it's a good reducing agent. So substances that form positive ion from neutral atom are reducing agents. So because they will donate electron, they will lose that electron before they can form a positive charge. So and when you lose electron, you are a reducing agent. So answer simply is that P is a reducing agent because it ionizes by losing electron. So that will be the end of this video. You see me in the next video for the continuation of the topic. Thank you.